Welcome again, Mindsetters. Now it's time for the matriculants. Grade 12s, it is your chance now in trigonometry. And I'm not alone. I'm having Lizzo. How are you, Lizzo?
I'm very well, thank you. And you, Abram?
I'm doing great. I'm looking forward for this great session and learning lesson as much as the Mindsetters are looking forward.
It's good to know that everybody's listening because, guys, we're going to be starting with the matric part of trigonometry involving, well, first we'll go over some things from grade 11, but we're going to have a look at the compound and the double angle identities, which often pose a bit of a problem.
Very interesting. Interesting indeed. I'm looking forward. While you're getting ready, please get ready. And Mindsetters, this is what's on for you. To get in touch on tonight's show's lesson notes, it's simple. Go to our website. It is www.learnextra.co.za/live. You can download those notes for free, and also you can get us on Facebook. We chat with you, ask any questions. Lizelle is here to help you. We're more than willing to help you guys. Our Facebook page, it is facebook.com/learnextra. Take it away, Lizelle.
All right, guys, so as I said before, in this lesson, we're going to revise some of the trigonometry from grade 11. So just in case you don't even know what trigonometry is anymore, don't fret, we'll fill you in. And then we're going to have a look at our compound angle and our double angle identities. These are very particular to grade 12. So let's waste no more time and have a look at some grade 11 revision. Now, what I'm going to do is write down some of the basic things that you should know, even if I wake you up in the middle of the night. So let's have a look at our trig ratios. Firstly, sine of theta. So we should know, because you've been doing this since grade 11, that sine is opposite over hypotenuse. So that is y over r. Definitely these sorts of things you guys should know, as I said, without even thinking about it twice. Then cos is adjacent over hypotenuse, and that, of course, is x over r. Finally, tan, and tan is opposite over adjacent, which is y over x, and of course, Dina used the y over x to get the angle of inclination in the previous lesson. So guys, this is the absolute very basics. What else should we know? If we're dealing with any one particular angle, sine squared of that angle plus cos squared of that same angle is equal to 1. This is called our square identity. Let me think what else. Tan theta is sine theta over cos theta. Very, very useful. And then let's have a look quickly at our different quadrants. Our first quadrant, quadrant number 1, runs from 0 degrees to 90 degrees. And in the first quadrant, all of our trig ratios are positive. So that means sine, cos, and tan, all of them are positive in the first quadrant. From 90 to 180, that is our second quadrant, and the only trig ratio that is positive in the second quadrant is sine. Then the third quadrant is tan only that's positive, and in the fourth quadrant, it is cos only that's positive. Right, so this is some of the basic information. It's not everything. I'm quickly going to be talking to you guys about our reduction formulae, because this is something that I find, certainly my students at school seem to be a little bit blank on it. So far, Abram, what's the feedback? Is everybody with us?
Everybody's up and ready now, getting ready, getting their pens ready, saying we are up for the game.
That is good.
So let's do this.
All right, guys, so let's just have a look at a couple of reductions. If somebody says to you, sine of 180 plus x. Now, when we do reduction, that is when we absolutely need our quadrants over here. Now, if I say 180 plus x, that means it is more than 180 degrees. Now, remember, x by convention is a acute angle. So x will then lie between 180 and 270. Now, the first thing that I need to determine is sine positive or negative in the third quadrant rather? Now, I have a look at my diagram and I see the only trig ratio that's positive is tan. So therefore, sine is not positive. So then this becomes negative sine x. Right, so very, very important. You've got to first establish where you are so that you have your angle for later on. Now, let's not forget about our co-functions. Sine of 90 degrees plus x. Right? So that is in the second quadrant. Now, that's not a problem at all. Sine is positive in the second quadrant, but we have to remember that sine changes to cos. So sine of 90 plus x will change to cos x. Even if it's 90 minus x, it'll still change to cos x. Or if I have tan of 90 plus x. So that's a 90 plus again. Tan changes. Now, firstly, I've got to determine whether tan is positive or negative. 90 plus x is in the second quadrant. Tan is not positive in the second quadrant. So I know that I'm going to be dealing with a minus. But then for tan 90 plus and tan 90 minus, it changes to 1 over tan x. Right, so let's just think about a couple of other things. Then there's also our special angles. Our special angles are those angles which we should be able to calculate without a calculator, but these days our calculators are so fancy that we can actually use the calculator. Nobody will know. Let's have a look. So our special angles are 30, 45, and 60. So let's say I am asked to simplify and I'm given cos 225, and especially if I'm asked to simplify without a calculator. Now, guys, you can't just bring up your calculator and say cos 225. You'll lose some marks there. What you need to do is first show me how you reduce the cos to a special angle. So what we're going to do is we're going to write it as cos of 180 plus 45. 180 plus 45 does give me 225, so I'm not telling any lies. And then I go back to my diagram and I say, all right, 180 plus 45, that is in the third quadrant. The only trig ratio that's positive in the third quadrant is tan, so this is going to change to minus cos 45. And once you've done this, you can bring up your calculator and you can say cos 45. And if you've been doing this as long as I have, you'll know the answer. It's root 2 over 2. So very important, whenever we're working with any sort of trigonometry, we've always got to determine where I am and do I have to make it a negative, do I have to make it a positive? We've got to be aware of the fact that all of the trig ratios are positive in the first quadrant. The second, it's only sine. Third, it's only tan. And the fourth, it's only cos. Any questions so far?
No, so far no questions, but I have a comment from Samuna Ali Khan saying, hey guys, yeah, love Lizelle. She makes it so simple, trigonometry for me. She does it. So that's a great one.
Well, let's see how simple this stays once I introduce the compound and the double angle identity.
That's a challenge for you, Sumay.
That's the challenge. Now, guys, the compound and the double angle identities are available on your information sheet. So the first thing that I want to say to you guys is do not spend any time trying to learn these off by heart. It's not a good idea. It's going to be there when you write your exam, right? So we don't have to worry about that. What we need to worry about is how to use them. And I'm going to start with the compound angle identities. So in very much the same order, this is going to appear on your information sheet. So instead of having sine of A plus B, I could, if it suited me, change it to sine A cos B plus cos A sine B. Now, the important thing to remember about these identities is, yes, they work from left to right, but they can also work backwards. Now, I'm going to start with a simple little sum that'll just show you how to deal with your compound angle identities. And we're going to be doing a little bit of grade 11 revision at the same time as well, because we are going to reduce some angles to first quadrant angles. Abram, have these kids seen this before?
I hope so.
I
really hope so. And I like what they're saying. They're saying, really, this is so simple so far. So far, so good. I hope you are really paying that attention. And if you are lost, get on the notes. We are on learnextra.co.za/live. Get those notes. They're for free. You can just be with us, get on the floor with Lizelle and I, and make sure that, guys, you get on the page too. Post your questions, post your comments. We are on facebook.com/learn extra. It looks like Lizelle is up and ready now to do some more stuff.
I'm ready for you guys.
Simplifying stuff.
Guys, so the instruction here will be to simplify, and most frighteningly, the instruction will be to simplify without a calculator. Now, do not be frightened by the fact that clearly 79, 311, 101, and 49 are not special angles. What we're going to start out by doing is just changing all of these angles to first quadrant angles. So really, what we'll be doing is revising some things from grade 11. So the cos 79, I am going to leave exactly as it is, because 79 falls between 0 and 90. Now for this baby over here, the cos 311, I'm going to say, well, hang on a second, that is cos of 360 minus 49. Okay, I'm just writing it at the top because I don't want to waste too much space. Now remember, in the fourth quadrant, cos is positive, so this can change to cos 49. No mess, no fuss. Right, then what am I going to do about the sine of 101? Well, guys, we always have to look for patterns, and I love it if things repeat. Now, I'm going to change that sine 101 to sine of 180 minus 79. Now, the reason I'm doing that is because I've already got a 79 going on here, and I know if I have repetition of similar things, that can only be a good thing. So, sine of 180 minus 79, again, we're working in the second quadrant. Sine happens to be positive in the second quadrant, so this changes to sine 79. And very fortunately, I've got sine 49 over here. Now, guys, have a look now at what happens. I have got cos of one angle, cos of another angle, plus sine of one angle, sine of another angle. Now, I'm going to look at my identities, and I'm going to see if I recognize this. I've got cos, plus sine, sine. So I know that if I have this pattern going on, I can write it as cos of 79 minus 49. And that's really cool, because what does that simplify down to? Cos of 30, and that is a special angle. So if at this point I quickly sneak in my calculator, nobody's going to know. Let's go for it. Cos of 30. And the answer is root 3 over 2. So what I've managed to do here is, without really using a calculator, and I promise you guys I can do the last step without a calculator, even if I'm stranded on a desert island. But what I've managed to do is take something that's really complicated, or looks really complicated. Firstly, I looked to change everything into acute angles. Also, while I was doing that, I was constantly aware of, if I have the same angles repeating, I could possibly use my compound angle identities. And that's how I've very easily managed to simplify this down. First, to the cos 30, and then finally to root 3 over 2. So that's the first little part of our lesson, working with compound angles. We're going to do some more of that pretty soon. Abram, take it away for our first break.
Thank you very much. It's time for us to just take a little break, and we'll be back right after this. But remember, guys, get over the page, get over the website, get the notes, get also the previous shows that we have through our YouTube channel that you'll get via our website, which is learnextra.co.za/live. See you after this for more trigonometry. Welcome back, Mindsetters, and I am definitely sure that you guys are really enjoying this show with Lizelle. But I should also say this for Mindsetters such as Noziz was saying, trigonometry is so challenging. Guys, it all takes practice. There is nothing that comes easy in life, and mathematics takes practice and more practice. But Lizelle, before we move right along, there's a question from K. Kosi that says, but isn't compound angles and identities for second term? And it's just a question that has been confusing a lot of Mindsetters. If you're still confused, Mindsetters, about the topic today that we are treating, which is trigonometry, it's simple. Get our free notes. We also have the fast link over the Facebook page. They are free, mahala, on learnextra.co.za/live. But you can also interact with me or Lizelle also on the page, which is facebook.com/learnextra. What is your view on that one, quickly?
Look, I'm not exactly sure because it's not my school that we're talking about, but
Yes.
the way I see it is if you can get in with a bit of a head start, that's never a bad idea. So we've gone through the basics of grade 11 trig. At least if the topic is started at your school, if you just have some sort of an idea of what they're on about, it might be to your advantage. Now, I've started by doing the first compound angle question where I literally worked from the right-hand side back towards the left-hand side. So because my question had two different terms, there was a sine, a cos, whatever, I simplified it and I took it to the left-hand side. However, you can also work the other way around. So let's say somebody were to say to you, calculate without the use of a calculator sine of 75. So just to get you guys a little bit used to how these rules work. Now, sine of 75 is a single term. Okay, I think I'm probably going to have to use my compound angle identities. Let's have a look at how I could do that. I can now say, but hang on a second. Can't I write 75 as a sum of two special angles? And the answer is yes, I can, because 45 plus 30 gives me 75. And what I can now do is I can use my first rule, that's sine of a plus b, and I can expand these guys and then simplify them further. So I'm going to change this into sine 45 cos 30, just using my rule. And remember, you don't have to learn it, plus cos 45, sine of 30. And this is now perfectly manageable. You can quite simply say, well, hang on a second, sine 45 is root 2 over 2. Cos of 30, didn't we just have cos of 30? Yes, we did. That's root 3 over 2. Then cos 45 again, that's root 2 over 2. And sine 30, which is a half, if I'm not mistaken. Wait, let me just check. Sine 30. Yes, that's a half. And you can then put this into your calculator. So it's important, if you start with lots of things, try and reduce them and move from the right-hand side back to the left-hand side. If you start with a single number and you are asked specifically not to use your calculator, try and see if you can't say one special angle plus another special angle, or even one special angle minus another special angle. Like, for instance, if I told you to do without a calculator cos of 15 degrees. Now, cos of 15 degrees can be written as cos of 45 minus 30, And in that manner, similar to the previous question, you can then expand and do it without a calculator. Right, guys, so that is an introduction to our compound angle identities. Now, directly from the compound angle identities, we get our double angle identities. So the double angle identities is if A and B are the same thing. So let's have a look at these. Once again, guys, nothing to learn here. The double angle identities will be given to you on your information sheet. Now have a look at this. This is quite interesting. If I've got cos of 2a, I have got 3 different options. I could write it as cos squared a minus sine squared a, or I could write it as 1 minus sine squared a, or I could write it as 2 cos squared a minus 1. If you're wondering where that comes from, it simply comes from substituting our old square identity, which we know, sine squared plus cos squared equal to 1, into the different places. Right, so this is given to you as well. And then, fortunately for us, there is only one double angle identity for sine. Now, as you guys get into this, you'll see that often one's biggest challenge is to pick which one of these you want to replace your cos with. But fortunately, sine 2a is 2 sine a cos a, and that's it. Now, similar to our compound identities, we can work from the left-hand side to the right-hand side, but we can also work backwards. So, we're going to have a look at our first question, Abram. That's if there's no other questions for us at this point.
All right, as we're getting ready to go to that question, I just have a quick comment that's from Simpiwe Mpangane saying, wow, it's my first time downloading the notes, and Lizelle, as the teacher, it's very easy for me to follow and understand. That's what we need, mindsetters.
Well, thank you very much. That's a lovely compliment.
Thank you.
All right, guys, so now here I am faced with another expression that doesn't have any special angles in it, really, and it's looking a little bit frightening, maybe. We have on the left-hand side 2 cos squared 40 degrees minus 2 sine squared 40 degrees. That is all then divided by 8 sine 10. And we have to prove that our expression on the left-hand side is equal to a quarter, 1 over 4. Now, very, very important, guys. When we are working with an identity, whenever we see the word prove, we cannot work with the left-hand side and the right-hand side simultaneously. We've got to work with the left-hand side on its own and manipulate our left-hand side until it looks like the right-hand side, or start with the right-hand side and show that it looks like the left-hand side. All right. So I'm going to start straight up, and I'm going to just quickly go back and just remind you guys of our square identities again. We've got cos 2a equal to cos squared a minus sine squared a. Then we've got that it's also equal to 1 minus 2 sine squared a, or 2 cos squared a minus 1. Now let's have a look at the question that we have here. I'm starting out by saying that the left-hand side is equal to. And now I've got to get on with the business of manipulating that left-hand side so that it looks like the right-hand side. Now, the first thing that I notice here is that I've got a cos squared minus a sine squared. Now, I had something quite similar over here. It's not exactly the same, but I do know that cos 2a is cos squared a minus sine squared a. So what I'm going to start off by doing is I'm going to take 2 out as a highest common factor. That's a trick that's often forgotten by not just our mindsetters, but just everybody forgets to factorize. Right. So I've taken 2 out as a common factor. I'm still putting it over 8 sine 10. Now, boys and girls, what I have staring me in the face, it might as well be slapping me in the face, is I've got my 1 cos double angle identity. I've got cos squared a minus sine squared a in that bracket. Now, I know that cos squared a minus sine squared a is cos of 2a. So let's have a look at how I'm going to apply it. I'm still going to write my 2 over here. And I'm going to say, well, that cos squared 40 minus sine squared 40 is equal to cos of 2 times 40. Right? And that is all divided by 8 sine 10. Now, immediately, I'm feeling quite excited because I'm seeing that 2 over 8 there, and I know that 2 over 8 can simplify to a quarter, so I'm not too far from the end. Let's have a look. I'm going to say 2 goes into 2 once, 2 goes into 8 4 times. So this becomes 1 over 4. And over here, I have cos 80. And at the bottom, I have got sine 10. Now, those of you that are more experienced will immediately know that you are able to cancel those two out. Why? The one is a sine, the other is a cos, and they are complements of each other. No, they don't tell each other that they're wearing nice shoes. They add up to 90 degrees, mathematical complements. So what I could have done, and you don't have to show this, but this is in case the questions start coming. This cos of 80, I could have written as cos of 90 minus 10. Right? Because 90 minus 10 gives me 80. And then when I reduce that angle, 90 minus 10, I say, but hang on a second, it's 90 minus, so cos changes to sine. So this is in actual fact sine 10. So it cancels out with the sine 10 at the bottom, and that is then equal to 1 over 4, which is equal to the right-hand side. Now, this step that I did over here in white, you don't have to show it. If you have a cos in the numerator and a sine in the denominator, and their angles add up to 90 degrees, you can cancel them. Similarly, the sine could be at the top, and the cos could be at the bottom. As long as they add up to 90 degrees together, then they are complements of each other, and you can cancel them out. Questions so far?
I have a question from Tracy Smarties Ndlovu saying that so compound angles have nothing to do with special angles, or they are.
Compound angles often lead us into special angles, but compound angles are something completely separate. So special angles is something that you can use towards the end of your calculation if you're doing compound angles. So really, it's all trigonometry. So in some way or another, it's all a little bit related to each other, but compound and double angles are exclusively metric work. So if you're on grade 11 and you're feeling a little bit confused, don't worry too much. There's no reason for confusion. Right, let's have a look at our next question. Now, the next question also says to us, simplify without the use of a calculator. So please, guys, don't go punching this into your calculator. No can do. We are not allowed to. So the first thing that we do is we change all of our angles to acute angles. Right. So let's have a look over here at the sine of 155. What could I do with that? Well, I could say that that is sine of 180 minus 25. So I'll leave that like that. The cos of 25 is already an acute angle, so there's not much I can do there. I'll just leave that. Right. Then let's have a look at our denominator. I've got cos of 320. So I'm going to change this to cos of 360 minus 40 degrees. So all I'm aiming for in my first step, and this is purely grade 11, is to get to acute angles. So this becomes sine 25 and cos 25. And in my denominator, also because cos is positive in the fourth quadrant, this becomes cos 40. Now, guys, if you have a little bit more experience, what you'll notice is that 25 and 25 do give you 50. It doesn't mean you can just add them together. And I've got a 40 in my denominator, and if I've got a cos 40 in my denominator and a sine 50 possibly in my numerator, that could work quite nicely. So let's have a look back at our compound angle identities. And this is the one that I want you guys to look at. This is now the sine one. If I have 2 sine 25 cos 25, I could go backwards and write it as sine of twice 25, which is 50. However, I'm not quite there yet, because if you guys look at our question, I don't have a 2 in front of the sine 25 cos 25. Now, guys, there's always a way to make things work for you. I'm going to put a 2 in there. Now, you might say, what is she doing? Has she gone absolutely mad? She can't just put 2s in if that suits her. It's okay for me to put the 2 in as long as I counteract it as well. So if I put a 2 in my numerator and in my denominator, what am I doing other than multiplying by 1? And I absolutely know that I am allowed to do that. So now I can work backwards and I can say, right, 2 sine 25 cos 25 can be written as sine of 2 times 25. And that's all over 2 cos 40. And then I can say, well, hang on a second now. I have sine 50 in my numerator. I have 2 cos 40 in my denominator. And remember the trick that I showed you guys just now? Sine at the top, cos at the bottom, or cos at the top, sine at the bottom. I am allowed to cancel them only and only if their angles add up to 90 degrees. And then I can go straight on ahead and do that. Let's cancel them out. And I am left with 1 over 2. Abram, how are things looking there? Are people still finding it simple?
Still simple, but I have a couple of questions that we would like to do after the ad break. Hope you'll be all ready, and the mindsetters will be all ready after the break. Now, guys, keep those questions coming. Facebook, we are facebook.com/learnextra, and the notes are for free, also on the Facebook page. We'll see you after this. Welcome again, Mindsetters, grade 12s. I hope you're having fun. And I must tell Lizelle that even grade 10s, grade 11s are tuning in. They're having fun. So I'm saying we really can't wait when we get to this trigonometry grade 12. But
that's good to know.
It's so great. Mindset is be alert, be alive. And that's what we're all about, being proactive, learning things, new stuff every day. But I've got a quick question for you before we move on. It is from Mpigeleli Petros saying, hi, can you help me by simplifying cos 3x?
All right, so just to give you a hint, I'm not going to do it right through to the end, but what I would do with cos 3x is I would start by making it 2x plus x, right? And then I'm going to go back to my compound angle identities. Now, I'm terrible. I don't remember them either. So it's going to be cos 2x cos x minus, and then sine 2x sine x, right? So cos 2x, if I can just find my page. So it's going to be cos 2x cos x, and then a minus, and sine 2x sine x. Now what I would then do from here, and this is often quite difficult, because now it's very difficult to decide which one of the ones you want to change your cos 2x to. So now you're going to simplify further using your double angle identities. Now, the sine 2x is easy. That changes to 2 sine x cos x. Now, that's 2 sine x cos x, which is already multiplied by a sine x, so that's going to be minus 2 sine squared x cos x. Now, very often, we try and look and see if we can't get a highest common denominator or something like that to take out. So my advice to you, for the cos 2x, try and see which one of these you think will work the best. You can maybe start with the cos squared minus sine squared, then maybe the 1 minus sine squared, or even the 2 cos squared a minus 1. Simplify that, multiply out, and see how things simplify for you. That would be my advice on that one, but definitely take the 3x into 2x plus x, and then use your double angle identities to take the 2x down to x's as well. So that question really incorporates your compound and your double angle identities. I think I've given you something to work with. Let us know if you don't get it right. Right, guys, but we've got more stuff to get through and plenty of people that want to get through it. So let's have a look at our next question. Our next question says, prove that sine x plus sine 2x over 1 plus cos x plus cos 2x is equal to tan x. Now, guys, remember, whenever we see those magic words, prove, we have to work with our left-hand side and our right-hand side separately. It is a mathematical sin equivalent to robbing grannies to work with these two things together, because if you work with these two things together, you are assuming what we are asking you to do. So please, left-hand side and right-hand side separate. Right. Let's have a look at what we can do here. So I'm going to start out with the left-hand side. I'm going to say left-hand side equals, just use another color so it's more interesting, and I've got a sine x here. Nothing I can do there. Then over here, I've got sine 2x. Now, sine 2x is a double angle identity, and I know that sine 2x will change to 2 sine x cos x. X cos x. Now, boys and girls, as I said earlier on in the program, often the biggest problem in a double angle identity is what do you do with a cos 2x? Because as we've seen before, there's 3 different options as to which one you can use. And while substituting either one of them in might be correct, it won't necessarily lead you to the correct answer. So what I sometimes do if I'm in a situation such as this is I hang on a little bit. I keep the cos 2x as cos 2x, and I'm going to work now a little bit in my numerator and see whether my further working doesn't perhaps give me a clue as to which one of these guys would be the best substitution. So for now, I'm just keeping it simple. I'm not substituting the cos 2x yet. It's not because I didn't see it. It's because I'm still working on a plan. So what you can even do is underline it for yourself so that you know you've still got to get to it. Now I'm going to go back to the numerator, and I'm going to say, right, what could I possibly do in the numerator? Now, Abram, have we got any suggestions? Anybody know what we can do at the top there? Something that I did mention earlier on tonight as well. It's an F word, but it's not rude. Factorize!
And you said it's something that everybody, almost everybody, always forgets.
So what I'm going to do at the top there is I'm going to take out sine x as a common factor. So I take out sine x as a common factor. I'm loving it. And I'm saying that I'm left with 1 plus 2 cos x. Right, Abram, just quickly tell us what's the buzz on the website.
The buzz for the website, it's simple. Mine it is lenextra.co.za/live. Or Facebook, we are facebook.com/lenextra. That's how simple it is. Lizzo?
Okay, now guys, now I'm starting to think to myself, if I look at the right-hand side, remember what I said when we were doing our grade 11 revision? On the right-hand side, I've got sine x over cos x, really, because on the right-hand side, I've got tan x. So tan x is sine x over cos x. So immediately, I'm feeling a little bit better because I'm seeing, hang on a second, I've got a sine x materializing here at the top. So what I need to get rid of is this bracket. And this now gives me a clue that perhaps it would be a good idea to stick with cos at the bottom. So what I'm going to do is I'm going to, in the place of cos 2x, I'm going to put 2 cos squared x minus 1. Now that's useful for 2 reasons. The first is this situation. I've got a plus 1 and a minus 1 that are cancelling out. So actually, I'm making things a little bit simpler for myself. Now, I mentioned just now, when you get stuck in a trig identity, what do? You factorize. Now, let's have a look and see. In my denominator, I can now take out, as a common factor, cos 2x. Sorry, not cos 2x, cos x. So I'm taking out cos x, and I'm loving it because I know that sine x over cos x is tan x, but let me not jump the gun. Let me write my leftovers in the bracket. That is 1 plus 2 cos x. And I love it when things work out. These 2 brackets are identical. They cancel out. I'm left with sine x over cos x, which is equal to tan x, which is equal to my right-hand side. So guys, sometimes it's a good idea to hang on just a little bit before you substitute the cos 2x. Maybe the rest of your sum will show you in which direction you need to work in. Now, we've got more lined up, but questions on this one in the meantime while we've got it here? Are we good so far?
So far, we're good, and I'm just having some great mindsetters being proactive over the page and helping one another, and that's what we really, really need.
That's what it's
Mindsetters
all
are on
about,
it.
helping each other. Right, let's have a look at the next question that I have in store for you. The question says, if sine 12 is equal to k, then determine the following in terms of k. Now, my students call these in terms of questions, and most of them don't like them too much. Now, guys, I'm going to give you a bit of a clue. If you want to make your life easier with a question like this, the best thing to do is to start off with a diagram. And this is how we're going to do it. I'm going to say, well, fine. Before I worry about the rest, I know that sine 12 is equal to k. But I don't just have to see it as k. I can see it as k over 1. Right, now if we think back about what I told you guys about our trig ratios, sine is y over r, or opposite over hypotenuse. So I'm going to say to myself, well, hang on a second. The y value is therefore k, and the r value is therefore 1. And I'm going to come up with a little sketch on the side here. I'm drawing my angle in the first quadrant because clearly sine 12 will be in the first quadrant. Let me fill in my angle there, 12. Then I'm going to say, but hang on a second. Y, or k, is my opposite. So opposite to my angle of 12, I am going to put k. Then 1 is my hypotenuse, or r, and the hypotenuse, or r, is always across from the 90-degree angle. So that's going to be over there. So on my diagram, I now have y filled in. I've got r filled in. The only thing that I don't have filled in is an x value here in terms of k. And guys, that's when that old Greek guy Pythagoras comes in very useful. Remember that x squared plus y squared is equal to r squared. X squared plus y squared is equal to r squared. And what I now want to do is I want to get an expression for x in terms of k. So I'm going to say x squared is equal to r squared, which is 1. And remember, 1 squared is still 1. Then I'm going to take the y over to the other side, changing its sign, but I'm going to replace it with k squared. And then I'm going to say, well, I don't want x squared. X will be plus or minus 1 minus k squared, but because I am working on the positive x-axis, this is going to be, let's use the same color, root 1 minus k squared. And once you've got this little diagram going on, there's absolutely nothing that you really can't do. So let's have a look at our first question. Our first question says that we must write in terms of k sine of 192. Nothing too bad about that. I'm going to change that to sine of 180 plus 12. So you guys will see it. At first, I'm not going to need that diagram, but I'm going to be happy that I did it eventually. So sine in the second quadrant is negative. So this changes to negative sine 12. But if sine 12 is equal to k, then surely negative sine 12 must be negative k. Right. So once again, I'm doing that age-old trick where I take angles that are bigger than 90 degrees and I bring them down to acute angles. At first, when you look at 192, you might not realize that it's got anything to do with 12, but you will see it sooner or later. Right, guys? Ready for the next one if there are no questions?
Someone says, Dinewo says, we're not good, Abram. She cancelled 1 plus 2 cos x. Can you explain more on that one?
Okay, so I'm back at my diagram over here. I'm saying k is my y value because that goes with the y over there. I'm saying 1 is my hypotenuse because that's over there. Now I'm saying Pythagoras said x squared plus y squared is r squared. Now I've got y. I know that y is k. I've got r. I know that r is 1. All I'm doing is I'm replacing the r, which is 1 over there. I'm saying 1 squared, which is still 1. And then in the place of y, I put k, so I get k squared, and then I take it over to the other side of the equation. So I get 1 minus k squared, and then x is the square root of 1 minus k squared.
So another question following that one, is it important for you to know the first step, which is where you got the root 1 for k?
This part is
Yes.
going to be really important later on, yes. So you will always be given one trig ratio. So I've got y and r, there's something missing, that's x. I need to use Pythagoras to work that out.
Okay.
Right, guys, I'm going to go straight on to the next one. Now this one can be done in a variety of ways. You could start out, depending on whether you know the 270 rule or not, you could start out by saying it's cos of 180 plus 78. Okay, because 180 plus 78 will give you 258. That's in the second quadrant, so this becomes minus cos 78. And then you can go, hang on a second, let's make this cos of 90 minus 12, which then changes, now the minus stays there, to sine 12. Alternately, if you know the 270 rule, you can use that one as well. We're running out of time, so I'm going rather quickly. This is equal to minus k. Right. Let's move on then to cos 336. Now, let's move on. I actually want to move on to the very last one because I think this is where we're going to need our diagram, and I just want to make sure that our mindset is don't think I did the diagram for nothing. So I'm going to say cos of 192 is cos of 180 plus 12. Right? That I know for a fact to be sure. 180 plus 12 gives me 192. Now, in the second quadrant, cos is negative. So this changes to minus cos 12. Now, guys, now I have a problem. I am already down to 12. But it's cos. And the question says to me that sine 12 is equal to k. And this is where my diagram now becomes important. I'm going to say, well, hang on a second. Cos is adjacent, my x value, over hypotenuse, my r value. And let's have a look back. In my sketch, I now have the adjacent value. That is the square root of 1 minus k squared. And I wouldn't have had that if I didn't do the diagram and the Pythagoras calculation. I also know that r is equal to 1. So thanks to that, if you hadn't done that sooner, you would have had to do it now. I'm now going to say it's cos is x over r, and in my diagram, r was 1 and x was 1 minus k squared. I don't need the y now, so I'm going to say 1 minus k squared over 1, and I'm keeping my answer completely in terms of k. So guys, as long as it was possible for me to change whatever they gave me to a sine of 12, no problem. I can just say k or minus k. But the moment I get to cos and it's 12, there's no way I can make it sine. And that is where that diagram is really, really, really important. Now, I think, Abram, if there's a bit of confusion over the diagram, then maybe when we take this up next term, we should put in another couple of questions like that. But guys, there's also no shame in copying down this question and taking it to your teacher at school, because if you're finding it a little bit weird, take the question and the solution, say to your teacher, talk us through this again, and it might be easier if you have somebody right by your side. Unfortunately, guys, all we've got time for, I'm going to give it to you, Abram, to take it away.
So true. Having said that, Lizelle, there's just a great advice that we have from a mindsetter saying that one thing that helped me is mastering the compound and double angle formula, and it went all smooth. But otherwise, mindsetters, you can also do the same thing. If you're struggling, get over our Facebook page. We're there to assist you, and go to your teachers at schools too. As Lizelle have said, we are on Facebook, which is facebook.com/learnextra. Guys, you can also download our notes. They're for free. You can get them on learnextra.co.za/live. Guys, it's been a great and awesome show. I hope you've learned a lot. From me, Abram, and Lizelle, we just want to say thank you very much. We'll see you on the other side. Guys, cheers. Learn more, do more with mindset. Thank you.
Of 180 plus x. Now, when we do reduction, that is when we absolutely need our quadrants over here. Now, if I say 180 plus x, that means it is more than 180 degrees. Now, remember, x by convention is an acute angle. So x will then lie between 180 and 270. Now, the first thing that I need to determine is sine positive or negative in the third quadrant rather? Now I have a look at my diagram and I see the only trig ratio that's positive is tan. So therefore sine is not positive. So then this becomes negative sine x. Right, so very, very important. You've got to first establish where you are so that you have your angle for later on. Now, let's not forget about our co-functions. Sine of 90 degrees plus x. Right? So that is in the second quadrant. Now, that's not a problem at all. Sine is positive in the second quadrant, but we have to remember that sine changes to cos. So sine of 90 plus x will change to cos x. Even if it's 90 minus x, it'll still change to cos x. Or if I have tan of 90 plus x. So that's a 90 plus again. Tan changes. Now, firstly, I've got to determine whether tan
Welcome again, Mindsetters. Now it's time for the matriculants. Grade 12s, it is your chance now in trigonometry. And I'm not alone. I'm having Lizelle. How are you, Lizelle?
I'm very well, thank you. And you, Abram?
I'm doing great. I'm looking forward for this great session and learning lesson as much as the Mindsetters are looking forward.
It's good to know that everybody's listening because, guys, we're going to be starting with the matric part of trigonometry involving Well, first we'll go over some things from grade 11, but we're going to have a look at the compound and the double angle identities, which often pose a bit of a problem.
Very interesting. Interesting indeed. I'm looking forward. While you're getting ready, please get ready. And mindset is, this is what's on for you. To get in touch on tonight's show's lesson notes, it's simple. Go to our website. It is www.learnextra.co.za/live. You can download those notes for free, and also you can get us on Facebook. We chat with you, ask any questions. Lizelle is here to help you. We're more than willing to help you guys. Our Facebook page, it is facebook.com/learnextra. Take it away, Lizelle.
All right, guys, so as I said before, in this lesson, we're going to revise some of the trigonometry from grade 11. So just in case you don't even know what trigonometry is anymore, don't fret, we'll fill you in. And then we're going to have a look at our compound angle and our double angle identities. These are very particular to grade 12. So let's waste no more time and have a look at some grade 11 revision. Now, what I'm going to do is write down some of the basic things that you should know, even if I wake you up in the middle of the night. So let's have a look at our trig ratios. Firstly, sine of theta. So we should know, because you've been doing this since grade 11, that sine is opposite over hypotenuse. So that is y over r. Definitely these sorts of things you guys should know, as I said, without even thinking about it twice. Then cos is adjacent over hypotenuse, and that, of course, is x over r. Finally, tan, and tan is opposite over adjacent, which is y over x, and of course, Dina used the y over x to get the angle of inclination in the previous lesson. So guys, this is the absolute very basics. What else should we know? If we're dealing with any one particular angle, sine squared of that angle plus cos squared of that same angle is equal to 1. This is called our square identity. Let me think what else. Tan theta is sine theta over cos theta. Very, very useful. And then let's have a look quickly at our different quadrants. Our first quadrant, quadrant number 1, runs from 0 degrees to 90 degrees. And in the first quadrant, all of our trig ratios are positive. So that means sine, cos, and tan, all of them are positive in the first quadrant. From 90 to 180, that is our second quadrant, and the only trig ratio that is positive in the second quadrant is sine. Then the third quadrant is tan only that's positive, and in the fourth quadrant, it is cos only that's positive. Right, so this is some of the basic information. It's not everything. I'm quickly going to be talking to you guys about our reduction formulae, because this is something that I find, certainly my students at school seem to be a little bit blank on it. So far, Abram, what's the feedback? Is everybody with us?
Everybody's up and ready now, getting ready, getting their pens ready, saying we are up for the game.
That is good to know.
So let's do this.
All right, guys, so let's just have a look at a couple of reductions. If somebody says to you, sine tan is positive or negative 90 plus x is in the second quadrant. Tan is not positive in the second quadrant, so I know that I'm going to be dealing with a minus. But then for tan 90 plus and tan 90 minus, it changes to 1 over tan x. Right, so let's just think about a couple of other things. Then there's also our special angles. Our special angles are those angles which we should be able to calculate without a calculator, but these days our calculators are so fancy that we can actually use the calculator. Nobody will know. Let's have a look. So our special angles are 30, 45, and 60. So let's say I'm asked to simplify and I'm given cos 225, and especially if I'm asked to simplify without a calculator. Now guys, you can't just bring up your calculator and say cos 225. You'll lose some marks there. What you need to do is first show me how you reduce the cos to a special angle. So what we're going to do is we're going to write it as cos of 180 plus 45. 180 plus 45 does give me 225, so I'm not telling any lies. And then I go back to my diagram and I say, all right, 180 plus 45, that is in the third quadrant.